Every AI agent you've used has the same dirty secret. They forget. Not gracefully, catastrophically. The moment a conversation exceeds the context window or a session times out, everything vanishes. Developers have fought this with increasingly desperate hacks, stuffing prior exchanges into system prompts, bolting on vector databases, summarizing old conversations into compressed tokens that lose fidelity with every pass. It's duct tape on a fundamental architectural flaw. In May 2025, Perplexity quietly launched something that reframes the entire problem. They call it space, and the implications reach far beyond search. SPACE stands for Sandboxed Processing and Autonomous Computer Environment. It's the infrastructure layer powering Perplexity's AI agent, branded simply as Computer. At its core, SPACE runs on Firecracker MicroVMs, the same lightweight virtualization technology Amazon built for AWS Lambda. Each task an agent performs gets its own dedicated MicroVM, its own file system, its own shell, its own isolated environment. When the task completes, the VM is destroyed. Nothing persists by default. Nothing leaks between sessions. Think of it as giving every AI action its own disposable computer, booted in milliseconds, killed without a trace. But here's where it gets genuinely interesting. Destruction alone isn't novel. What SPACE adds is rolling memory snapshots, full VM state captures taken every 60 seconds. These snapshots persist for up to 1 week. If an agent needs to resume a task, it doesn't reconstruct context from conversation logs. It restores the entire computational state, every file written, every environment variable set, every process running. The agent doesn't remember what it was doing. It literally picks up exactly where it left off. This is not memory in the way language models use the word. This is state preservation at the infrastructure level. The dominant paradigm for giving AI agents memory is prompt injection. You take what the model said before, compress it, and paste it back into the next prompt. This approach degrades in at least 4 ways. Summarization is lossy, details vanish, token budgets create hard ceilings, the model can hallucinate prior context it never actually had, and latency grows linearly with history length. Snapshot-based restoration sidesteps all of this. The model doesn't need to remember because the environment remembers for it. Context isn't linguistic, it's computational. There is no summarization step, no token tax, no hallucination risk on prior state. For developers building agent systems today, the most immediately actionable idea from SPACE is file system isolation. Giving each agent task its own sandboxed file system means the agent can write code, save intermediate results, install dependencies, all without any risk of corrupting shared state or leaking data between users. This isn't theoretical. Firecracker MicroVMs provide kernel-level isolation. The agent operates with real shell access, not a simulated terminal. It can execute arbitrary commands. If something goes wrong, the VM is destroyed. The blast radius is exactly 1 task. This is the kind of safety architecture that makes autonomous code execution viable. Conventional stateful agents require a persistence layer, typically a database or object store where session data lives between interactions. This introduces complexity, serialization formats, schema design, query logic, consistency guarantees. SPACE eliminates this layer entirely. The snapshot is the database. Every file, every running process, every piece of ephemeral state is captured as a single atomic image. Restoration is a VM boot from that image. No ORM, no migrations, no cache invalidation. For builders who have wrestled with maintaining agent state across sessions, this pattern is liberating. The infrastructure handles persistence, the agent just computes. a clear architectural pattern is emerging across the most capable agent systems being built in 2025. 4 layers. At the base, a MicroVM sandbox providing isolation and real compute. Above that, a snapshot mechanism providing stateful continuity without databases. Then, MCP, the Model Context Protocol developed by Anthropic and now adopted broadly, providing standardized tool integration, letting agents connect to external services through a unified interface. At the top, a long-context language model providing reasoning, planning, and natural language understanding. This stack, long-context model plus MCP plus MicroVM sandbox plus snapshots, is becoming the reference architecture for production-grade AI agents. Each layer solves a distinct failure mode that plagued earlier designs. The reason this stack works is that it pushes complexity out of the model and into the infrastructure. Earlier agent frameworks tried to make language models do everything: remember, plan, execute, recover from errors, all within the prompt. That's asking a text predictor to be an operating system. Space and architectures like it acknowledge a simple truth: models should reason. Infrastructure should manage state, isolation, and execution. The model decides what to do. The MicroVM does it. The snapshot preserves it. MCP connects it. Each component stays in its lane. Perplexity's space isn't the final form of this architecture. It's an early, opinionated implementation. But the principles it encodes, ephemeral compute, infrastructure-level state, real execution environments, clean isolation, are likely to become baseline expectations for any serious agent platform. The builders who move first on these patterns won't just have better agents. They'll have agents that can actually be trusted with real work. The shift from prompt engineering to infrastructure engineering for AI agents is underway. Space is one of the clearest signals yet of where it's heading.